until 10 tons. New varieties may reach 12 tons of dry weight per year are generally 3 until 5 times greater than the yield for certain pine trees, which can take from 7 years to reach habitable size. Growth of kenaf. First, rapid growth. Kenaf reaches 12 until 18 feet in 150 days. While certain pine, a species commonly grown on tree plantation, must grow 14 to 70 years before it can be harvested. Second, height yield. Kenaf also yield more fiber per acre than certain pine, producing 5 until 10 tons of dry fiber per acre, or approximately 3 to 5 times as much as certain pine. And third, exceptional papermaking characteristics. Less chemical, heat and time are required to pulp kenaf fiber because they are not as tough as wood pulp and contain less lignin. An average kenaf plant contains only 9% lignin, while certain pine contains 29% lignin. Lignin is a resin that binds the cellulose fiber in plants or trees together. Toxic chemicals such as chlorine are predominantly used to delignify and blanch wood pulp. Kenaf can be quickly and easily pulped and blanched with harmless chemicals such as hydrogen peroxide. Plant component partition and composition. Yield component measured with 5 kenaf cultivars in Oklahoma over a 2-year period produced plants at harvest which averaged 26% leaf and 74% stalk. By weight, in the same research, the kenaf stalk average composition was 35% bark and 65% woody core bark. The outer of the kenaf stalk contains the long fiber strands that are composed of many individual smaller fibers, normally called basic fiber. These individual base fiber, held together by lignin, are the building blocks of the base fiber strand, which historically were used to make the cordage product. The woody core material of the stalk, the portion remaining when the base is removed, contains core fiber. The individual base fiber are longer and thinner than the individual shorter, thicker core fibers. Wool stalk kenaf that is base and core fiber has been identified as a promising fiber source for paper pulp. The base and core kenaf fiber can be pulped together or separate and pulped individually depending on the pulping process and the paper pulp to be produced.
Wool stock. Wool stock kenaf can be pulped by craft, soda, neutral sulfate, mechanical, chemi-mechanical, thermomechanical, and chemi-thermomechanical process. Wool stock kenaf will have been processed into high quality wood. Certain size contain raw stock and newspaper paper. Commercial presses have printed on kenaf paper using letterpress, offset, rotogravure, flat wrap, and interleave section piece. The combined base and core bleached fiber yield from chemical pulping is about 46% by weight. Wool stock kenaf can also be used in corrugated medium. The wool stock plant material can also be used in non-pulping products such as welding materials such as particle board and return injection molded and extruded plastic. Unlike the pulping process with wool stock plant material with power tanks. For 46% by weight. The use of non-pulped wool stock material is nearly 100% usable material. The difference is the result of the intentional removal of non-fibrous materials such as lignin and sugar during the pulping process, where the removal of just intercalculate material is not required for the non-pulped product.
For the core, chemical pulping of the woody core will use about 41% fiber from the original woody portion of a canal stock. The core fiber make up from 20 to 40% of the entire stock by weight. The average length of the core fiber range of 0.49 to 0.78 mm long, with average length 0.6 mm and average diameter of 57.4. The core pulp, compared to hardwood pulps, has a lower shear strength, but a greater tensile and burst strength. Due to the high absorbency of the woody core material, researchers have investigated the use of knife as an absorbent and as a polyurethane in animal bedding, as a bulking agent from service sludge, compositing, and as a portion soil amendment. In addition to the above core products, which are all new available in the marketplace, several knife core products are available which are successfully used for toxic waste cleanup, oil spills on water, and the elimination of chemically contaminated soil. For the base fiber, when base material is mechanically pulled out from the core into a chemically pulp without the core, it produces a 57% yield of base fiber as mentioned earlier. On a wool stock dry weight basis, the base comprise 70.4% to 28.6%. The individual base fiber are up to 5.0 mm long, averaging 2.6 mm in length and 20 mm in width. Chemical base pulp is well suited for specialty papers such as high quality stationery or filter paper. Base pulp, compared to softwood pulp, has a similar tensile strength but greater shear strength and bark fiber, thus it could serve as a replacement for softwood pulp. Pulping kernel base and core fiber can benefit the environment because the process requires fewer chemicals and less energy compared to standard pulping processes.
The kernel fiber can also serve as a virgin fiber for increasing recycled paper quality and paper strength. Although the kernel-based fiber strengths were once only considered for use as a condensed fiber in such products as rope, twine, carpet, and burlap. A variety of additional uses has developed for the base fiber strands as shown in this include use in automobile dashboard, carpet, padding, corrugate medium as a substitute. For fiberglass and other synthetic fibers, textile and S fibers, for injection molded, extruded plastic, kernel-based fiber strands are presently in commercial use in other environmentally friendly products such as fiber lawn mat impregnated with graphite and spray on soil for use along highway, right of way, or construction sites to prevent soil erosion from water. For general properties of kernel fiber, raw kernel fiber obtained from outer bark is actually a bundle of lignocellulosic fiber bundle size depends on the number of ultimate cells in each bundle. Most lignin is present between the ultimate cells. Knaf contains approximately 65.7% cellulose, 21.6% lignin and pectin, and other composition. Lignin must be extracted to spread the fibers. The physical dimension of the fiber are one of the most important factors in apparel industry. Knaf single fibers are only about 1 until 7 mm long and about 10 until 30 microns wide, and thus too short to textile processing. A specific average length is not used because of the wide variability is the simple study. The measurement of single fiber dimension can be achieved by various methods. A large part of these differences is probably due to such factors as cultivar, location and climate. Besides the differences in the techniques, factors are used to analyze. In addition, fiber characteristics are also probably dependent on the maturity of the plant. The most economical process is projection the image from the microscope on the wall or on a board. So the fiber dimension can be measured manually or by a digitizer. By using an electrode indicator, digitizing can be achieved by identifying both ends of the
Knaf
fiber.
fiber image the cellular structure of knaf can be separated using discretion method. And generally speaking, the leg knaf fiber are coarser at the bottom of the stalk and longer at the top. The increase in length from the bottom to the top was not gradual but speed. There is more variation of the fiber leg at the top of the stalk. Also, the longer fiber are located at the top. On the other hand, different parts of the plant have different mechanical properties. That is the chemical proportion and fiber properties of the plant. Each tissue taken from the root, stem, trunk, and leaf are different. And the mechanical properties of plant tissue are also different at different stages of the growing session. Fiber leg increases in the early part of the growing curly and then disperses again as the plant matures. This may be an advantage in harvesting fiber and also time thinning that from a material. The conclusion is from the research that we have done, the knaf can using the replace with the commercial wood in the paper making. This is because of the lacking of wood source and the price of wood is very expensive. So there are also alternative that we can take to replace the solid wood. The knaf can be used to replace that other resource in paper making. This is because knaf plant had the more fiber than the solid wood. Not only that, the paper that made from knaf fiber has a high quality when the process is done. Besides that, the growth of knaf is more faster than the other commercial wood. This knaf plant alternative that can be take this. The one